Now we get into some more probability rules. And I really like the way that we're going to do this first part. It makes a lot of sense to me. So let's take a look. Remember that if A and B are disjoint, which is the same thing as saying mutually exclusive, the probability of A or B, and when it's this way it's or, when it's the other way it's and the way I remember it is the one that looks most like an A is the and, is the probability of A, be nice if I had this on the right thing, plus the probability of B, if they're mutually exclusive. But in a lot of cases, the stuff is not disjoint. And this is where it becomes really more interesting. So let's look at this one. According to spots.com, it's a real thing, or at least was at one time, of the 119.6 million households in the US, 63.4 million or 53% own a dog, while 42.7 million or 35.7% own a cat. Assuming that 17.9 million or 15% of American households own both a dog and a cat, what is the probability that a household chosen at random will own either a dog or a cat? Now, the mistake that people will make on this is that they'll add the probability that they have a dog to the probability that they have a cat. What's the problem with that? Some of them have both. Okay? And that is what we're going to do. We're going to end up subtracting that, but I'm going to show you why we should subtract it. Okay? So we're going to make a table, and we're going to have dog, no dog, and cat, no cat. All right, this square would represent what?
15% households.
Right?
Ooh, that's good.
Because that's both dog and a cat. So this is going to represent the total percent that own a cat. 35.7%. So from that, we can figure out what the percentage would be here. We're not going to just yet, but you could, right?
Yeah.
And then we know the total percent that own a dog, 53%. So this is going to be totals here. And we also know what total percent don't own a cat, what total percent don't own a dog, all those kinds of things. Okay? I'm just like...
I'm just looking at the problems today.
All right. So there are a couple of ways that you can do this. I'm going to go ahead and find this percentage. That's going to be, what, 20.7%? And this is going to be, what, 38%?
Yes.
One way that we could do this then would be by adding these percentages together. The ones that I have in the heart of the table, right? Because this would be owns both, owns a cat but not a dog, owns a dog but not a cat. Add them together, that should be all the ones that own a pet. So one way to do it would be to take 15% plus 20.7% plus 38%. So when you add those together, you get 73.7%. The other way to do it is the way that Liam was talking about. You could take the total of the dog owners, the total of the cat owners, but the problem with that is you've counted the ones who owned a dog and a cat twice. You just subtract this amount. So you could do 53% plus 35.7% and subtract the 15% that you've counted twice. This also comes out to be 73.7. So there's a couple of different ways that you can approach that. You could do this with numbers just as easily as you could do it with percentages. And again, part of why I like this is that this grand total has got to be 100%, right? Which means we can figure out any number that we want in this table, not just the one that we used to figure out this. Anything they want to ask me, I can fill in all these blanks and we're good to go. So like, for example, I know that this is 47%. And I know that this is 64.3%. So this is what, 26.3%? Your book sort of prefers that you do a Venn diagram. For me, I don't like them as much. You're welcome to do them that way. It doesn't make quite as much sense to me. That, and I don't think you have every number on the Venn diagram. You just have how many are. You don't have anything about how many do not. Sir?
I know we counted the 15% twice. I'm confused why we only subtract like 15%, not 30%. Because wouldn't we have to subtract from both percentage values for like households that own a dog and households that own a cat? Subtract 15 from both of those? Or, like, I guess I don't understand why we're not subtracting from both of them.
That would be the percent that own a dog but not a cat plus own a cat but not a dog. If you subtracted the 15% twice, you would get these two added together.
Oh, that makes sense.
The cat but no dog and the dog but no cat.
That makes more sense.
So yeah, we just have double counted this group if we just add these two together.
Yeah.
So we just need to subtract away that other part.
That makes sense.
Okay, so a Venn diagram, I am going to show you this. Like I said, I don't like it as much, but it's going to look sort of like this. So you're going to have cat, dog, this will be both. So this will be the 15%. And then you have to subtract it to find like this one. This is cat but no dog, which is 20.7%, and dog but no cat, which is 53%. No, sorry, 38%. So you can do it that way also. This does answer the question. You just add these three together and you would get what percent owned that pet. But any other question where they ask you about, they owned a cat but not a dog and all those other things, it doesn't answer those. I like the table better. Now, you may prefer this because it's like, oh, there's less to write here. And that's true. But other questions, it's not as helpful. So, here, what did we add together? Well, we added these two together. So, owned a cat, owned a dog, subtracted that they owned both. So the probability that you have A or B is going to be the probability of A plus the probability of B minus the probability of A and B. Because when you add those first two together, you've double counted the ones that had both. Notice that if A and B are disjoint, in other words, mutually exclusive, the probability of A and B is 0. And so it still fits this first rule. So you can use this anytime. That's why it says for any event, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. God bless you.
Thank you. What was it? Oh, I was gonna say something. That's close.
So at a particular high school, 40% of students are in band, 25% are in choir, 12% are in band and choir. What is the probability that a student chosen at random is in band or choir? So, well, that's just going to be 40% plus 25% minus the 12% that's in both. It's 53%. For that question, this rule is great, but they'll also ask you other questions. So using the band choir example above, what are the probabilities that a student chosen at random is either in choir or band, but not both, and neither band nor choir? And after a while, my head starts spinning if I try to figure it out. That's why I like the table. So, band. No band. Choir. No choir. So band and choir was 12%. Total for choir was 25%. Total for band was 40%. So now I want to know either in band or in choir, but not both. So I need to know these two numbers, right? All right, so just subtracting, this is 28%. And this is 13%. So it's just 28% plus 13%, which is 41%.
There's when we'd be able to just subtract the percentage in both twice, right?
Yes. So you would have to subtract this 12% twice, but if you start having to make up rules for all of the different possibilities, I get overwhelmed. It's like it's too many. The general addition rule is great, but trying to come up with a rule for every possibility get to be a bit much. And it doesn't take long to make this table.
So that middle percent is 41%?
This
The middle's around the table.
the middle.
Would be 41.
Oh, here?
Yeah. Or would it be 40,
Well, let's see.
47?
So this is going to be 75%.
And then if you subtract.
So this is going to be 47%.
Yeah.
Yep. And this would be 60, which works out.
Okay.
Okay. So that's the neither band nor choir. It's right there. 47%.
Is that number just also the inverse of the first probability we did about like a student being in band or choir?
Yes. Yeah, this is also 1 minus 100% minus 53%,
Yeah.
which makes sense. But again, the table helps me.
Yeah, I just don't think I like the table.
Pardon?
I just don't think I like the table.
Okay, no, that's fine.
The table is good.
I love the table.
Y'all
Matter
love
of
the
fact,
table.
the table's saving.
All right.
The
So-
table's saving ship.
Table's saving.
Often, we are interested in knowing the likelihood of one event given that another event has already occurred.
Oh, goodness. Oh, good.
This is called conditional probability. Okay? For example, what is the likelihood of someone getting lung cancer given that they smoked 2 or more packs of cigarettes a day for 20 or more years? It seems like that's pretty high, but I don't know. We've actually already done this. Way back in chapter 2 when we looked at contingency tables.
I remember this. I was good at these.
I like contingency tables also. Again, this appeals to the structure of how I like things.
Super exciting.
So let's use the Titanic class and survival table below to find the following percentages. The percent of first class passengers that survived. So of the first class passengers, so we're only looking at this column, what percent survived? So that's 203 out of 325. And that comes out to be 62.5% approximately. It's the worst looking 3 ever. The percent of those who died. So now what are we looking at?
Total died.
So we're looking at the dead row, right? That sounds horrible, doesn't it? So we're looking at the dead row and we want to see how many of them were third class. So that's 528 out of 1,490. And that's 35.4% approximately. Again, these rarely come out to be exactly percentages. What I usually suggest, and it's not my original idea, is go one more decimal place past whatever you have. You have whole numbers, go to the nearest 1/10 of a percent, etc. All right. Now, let's verify the same values from the previous examples can be found using contingency tables with the percent of table values. Okay. So for part A, we would have, here we had 203 out of 325, right? We were looking in the first class column. So if we're doing it with percentages, does it still work? 9.2% out of 14.8%. That turns out to be 62.2%. Which is almost exactly what we got here. Now, probably these numbers weren't exactly, it wasn't exactly 9.2%. So they rounded that off, and that's why it's slightly different. And statisticians shrug at things like that. They're like, yeah, that's close enough.
Huh.
Sorry.
It's only like a couple of people.
Yeah, what's a couple of more dead people here or there?
It's okay. We shrug it out.
All right, and then here we're going to be doing, we did the 528 over 1490. If we do it with percentages, it's 24.0% over 67.7%. And that comes out to be 35.6%. So it's the same thing, whether you use percentages or whether you use numbers. So here is the conditional probability rule. So what we did on this very first one, well, let's look at this one. Of the people in third class, the percentage who died who were in third class. So we did these two numbers, one divided by the other, right? This number is the probability or the percentage that were in third class that died, right? Divided by the total number that died. If we do that as a probability, so it's this number and this number. It's the probability that they were third class and they were dead divided by the probability that they were dead. Okay, so this is called conditional probability. Shh. So the probability of B occurring given that A has already occurred or that we know they belong to this other group. It's the probability of A and B divided by, so notice, given that they are A, that's the probability that it's A. Just like up here, given that they were dead, what was the probability that they were in the third class?
34. Oh wait, no, 5.6. Yes.
Okay, to do that, this 24% is the probability that they're third class and dead, and we're dividing by the probability that they were dead. Okay? This is an important formula. You need to know this one. So, using our pet example from earlier, where 53% of U.S. households own a dog, 35.7% own a cat, and 15% own both a cat and a dog, what's the probability that, missing the E in household there,
It's okay.
the household that owns a cat will also own a dog?
Let's get that chart out.
Okay? So that owns a cat. You don't need the chart. You do not need it. Yep. That owns a cat. So we already know that they own a cat. So the probability that they own a dog given that they own a cat is going to be the probability that they own a dog and they own a cat divided by, and it's always this last letter here, the probability that they own a cat. Probability that they own a dog and a cat is what? 15%? Probability that they own a cat? 35.7%. That comes out to be 42%. All right, let's go back up. to here. So, given that they own a cat, so we're in this row, columns go up and down.
Second, I said.
The probability that they will own a dog, given that they own a cat, isn't that what we just did?
Yes.
Oh, yeah.
That's conditional probability.
Check mark.
If you've got a table, you can figure out the conditional probability, but you can also just do this. All right. So, what's the probability that a household that owns a dog also owns a cat? So, the probability that they own a cat, given that they own a dog, you have to have the order right because they aren't going to be the same. So, this is going to be 15%, the probability that they own both, divided by the probability that they own a dog, which is 53%. And that comes out to be 28%. Let's see. All right, we're going to stop there. I'm going to hand back your test.